In today's fast-paced and interconnected world, the demand for agile and secure network infrastructures has never been greater. Traditional network architectures often struggle to keep up with the ever-evolving requirements of modern businesses. This is where Software-Defined Access, SDA, and Cisco DNA Center come into play, offering a revolutionary approach to network management and control. The controller is the heart of the SDA architecture and acts as the central intelligence for managing the network. Cisco DNA Center is an example of such a controller. It provides a single point of control for the entire network infrastructure, allowing network administrators to configure, monitor, and troubleshoot the network in a centralized manner. To interact with the network devices, the controller uses Application Programming Interfaces, APIs. APIs are sets of rules and protocols that allow different software applications to communicate with each other. In the context of SDA, the controller communicates with network devices, switches, routers, etc., through various APIs, enabling seamless integration and control. Software-based interfaces, SBIs, play a pivotal role in enabling the controller to effectively communicate with the network infrastructure and exercise control over the connected devices. These interfaces serve as the conduits through which the controller sends configuration instructions and gathers essential status information from various network elements. In the context of the SDA architecture, several common SBIs have been adopted to facilitate seamless interactions between the controller and the network devices. Among these interfaces are ****, Telnet, and SSH. These secure remote access protocols are instrumental in managing devices within the network. They provide administrators with the ability to access devices remotely, configure settings, and execute commands securely. ***, SNMP, Simple Network Management Protocol. As a widely used network management protocol, SNMP empowers the controller to actively monitor the network's health and performance. By querying devices for critical information such as bandwidth utilization and device status, SNMP facilitates efficient network management and timely troubleshooting. ***, NetConf, Network Configuration Protocol, and RESTConf. Representing modern configuration protocols, NetConf and RESTConf offer programmatic access to network device configurations. They enable the controller to retrieve, modify, and apply configurations across the network in an automated and standardized manner. These interfaces are particularly valuable in dynamically adjusting network settings to match the desired state based on the intent-driven policies defined by administrators. Through the utilization of these diverse SBIs, the controller can seamlessly communicate with the network elements, ensuring efficient network management, robust security, and swift responses to changing business needs. These interfaces act as the essential links that bind the intelligence of the controller with the agility of the network infrastructure, creating a cohesive and dynamic software-defined access environment. In the SDA, Software-Defined Access architecture, the network infrastructure is known as the fabric. This fabric serves as the foundation for the system, handling the actual data traffic and establishing connectivity between various devices. The architecture consists of two key components, the underlay and the overlay. The underlay pertains to the physical network infrastructure, encompassing switches, routers, cables, and wireless links. Its primary role is to facilitate straightforward packet forwarding among network devices. On the other hand, the overlay is a higher-level abstraction built upon the underlay. It utilizes tunneling protocols like VXLAN to transport Layer 3 protocols, such as IP security, IPsec, and control and provisioning of wireless access points, CAPWAP. Unlike the underlay, the overlay does not concern itself with the physical connectivity of devices. Rather, it focuses on logical connectivity and the enforcement of policies for more efficient and flexible network management. By separating the underlay and overlay, the SDA architecture enables greater agility and ease of deployment, making it a promising approach for modern network infrastructures. The proper configuration of the underlay network is essential to ensure the successful implementation of the SDA architecture. Within the underlay, various devices have distinct roles that contribute to the functioning of the fabric. Firstly, the fabric edge node, which operates as a switch, establishes connections with endpoint devices like user computers and IoT devices. It serves as the entry and exit point for these endpoints to access the SDA fabric. Secondly, The Fabric Border Node, also a switch, connects the SDA domain to external devices outside the architecture. These devices could include switches that connect to WAN routers or other networks not utilizing the SDA approach. Lastly, the Fabric Control Node, another switch, assumes specific control plane functions for the underlay. Due to its responsibilities in managing the control plane tasks, this node may require additional CPU and memory resources. The proper configuration of these components ensures a robust and efficient underlay network, forming the backbone of the SDA architecture. In the SDA architecture, data traffic is transported through the overlay using VXLAN, Virtual Extensible LAN tunneling. When an endpoint, such as a user's computer, sends a data frame, it undergoes encapsulation within a VXLAN tunnel before being transmitted across the SDA fabric. The VXLAN tunneling process can be summarized in several steps. First, the endpoint initiates the process by sending a data frame. Next, the frame is encapsulated according to the VXLAN tunneling specification. Once encapsulated, the frame is forwarded to the underlay fabric. Subsequently, other nodes within the underlay participate in forwarding the frame based on the VXLAN tunnel details. As the frame reaches its final destination, the last SDA node removes the VXLAN details. Finally, the frame is delivered to the intended destination endpoint, successfully completing the data transmission process through the SDA architecture. In the SDA architecture, policy management is streamlined using security groups and tags, SGTs, eliminating the need for writing new access control entries, ACEs, with every policy change. Instead, policies are defined centrally in Cisco DNA Center. Each policy is associated with a specific security group, identified by a unique tag, SGT. Cisco DNA Center takes care of configuring the fabric devices to enforce these security policies based on the assigned security groups. When a permit action is detected between the source and destination SGT pair, DNA Center instructs the edge nodes to create the VXLAN tunnel. This method greatly simplifies the management of security policies, as each security requirement can be independently considered without affecting other policies. This centralized and flexible approach to policy enforcement enhances security and eases the burden of policy administration within the SDA architecture. Cisco DNA Center plays dual roles, serving as both the controller for SDA, software-defined access, and a comprehensive network management platform. As the SDA controller, it takes charge of managing and configuring the SDA-enabled network devices, acting as a centralized point for network control and automation. Simultaneously, Cisco DNA Center serves as a network management platform for traditional, non-SDA network devices, providing a unified dashboard for provisioning, configuration, monitoring, and troubleshooting across the entire enterprise network. The platform's features are designed to simplify network management, reduce costs, and expedite deployment time. Notable features include EasyCoS, which streamlines quality of service deployment, encrypted traffic analysis for detecting threats in encrypted traffic, Device 360, and Client 360 for comprehensive device health views and network time travel, enabling historical client performance analysis. With these capabilities, Cisco DNA Center significantly enhances network operations, offering a robust and efficient solution for modern enterprise networks. Overall, the Cisco SDA architecture provides a flexible, secure, and scalable solution for modern enterprise network management, enabling policy-based segmentation and automation for enhanced network control and efficiency. We hope this video helped you on your journey towards becoming a cybersecurity expert. Remember to subscribe to our channel and turn on notifications so you never miss out on our latest content. And if you found our videos helpful, please give us a thumbs up and share them with your friends and colleagues. Don't forget to check out the links and description for our Anki flashcards and to donate to St. Jude Children's Research Hospital. Your support can make a real difference in the lives of those in need. Thanks again for watching, and we'll see you in the next video.